We're now going to look at our last special cases, the sum of cubes and the difference of cubes. And so suppose we start with a plus b times a squared minus ab plus b squared. And notice this almost looks like a perfect square trinomial, but it's missing the 2, so it's not. Well, if we multiply this out, we'll end up with a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed. And when I add these together, I get a cubed. That's eliminated. The b squared and the a squared b's are eliminated, and we're left with a cubed plus b cubed. So if I see a cubed plus b cubed, it always factors as this one. Likewise, a minus b times a squared plus ab plus b squared will is a factored form of a cubed minus b cubed. So the real key here is, can you recognize a perfect cube or not? So let's look at some examples. Let's start with an easy one. Suppose I have a cubed plus 8. Well, a cubed is a perfect cube of a times a times a is a cubed. Likewise, 2 is a perfect cube of 8. 2 times 2 is 4 times 2 is 8. So now I just go to my formula, which is the same, then a squared opposite, and then always positive on the b squared. So here's my a, and here's my b being plugged in. So we come here and we say this is a plus 2, a squared minus a times 2 is 2a plus 2 squared is 4. And so this is my factored form answer of a cubed plus 8. Always, always, always write the formula out and use it. Suppose that instead I have 27a cubed minus 64b to the 6th. Well, 27 is 3 times 3 is 9 times 3 is 27. So this gives me 3a as my a. And 64 is 4 times 4 is 16 times 4 is 64. So I get 4b. And in order to get something cubed to get 6, I need to divide it by 3, and that gives me 2. So I have 3a and 4b squared. Now because of the minus, I need to use a different formula. My formula is a minus b, always the same to start, positive, opposite ab, always positive for b squared. So here's my b. So using the formula, I get 3a minus 4b squared. Then I get the quantity 3a and I square it. Then I multiply the 3a by the 4b squared, and then finally I end with the 4b squared squared. This ultimately gives me 3a minus 4b squared times 9a squared plus 12ab squared plus 16b to the 4th. And this right here is my final answer. This is the factored form of that. Want to look at one last example. Suppose I have 2a to the 5th plus 250a squared. Notice that 2 and 250 aren't perfect cubes. Neither are a to the 5th or a squared. But I have a factor in common. I can pull out a 2a squared. When I do that, that leaves behind a cubed plus 125. A cubed is the perfect cube of a, and 125 is a perfect cube of 5. So I can use my formula. Again, a plus b, a squared minus ab plus b squared. And then I just plug in the pieces where they belong. Don't lose this 2a squared. Since we started with the 2a squared, we end with the 2a squared on the outside. Then we get a plus 5, a squared minus 5a plus 25. And this whole piece, including the GCF, is my factored form.